So I just want to shake the hands of the judges really quick. I know you're writing. I'm sorry. I just have to have some type of break the touch barrier here. Thank you very much for coming. And I just wanted to thank the Vibe for, this is the biggest presentation I've ever had. So I just want to thank the Vibe. I want to thank my buddy Naga. I want to thank my mentors, David Hirschberg and Dane Jessen. My family's here, so I also want to thank them for being here and supporting me. And some of my research, neuroscience research group came out as well. So I'm very appreciative for all of you. So many people think that parasites are gross and that they deserve no place in society, but I don't. I think they're awesome, and I think we can use them to solve problems. So I used to work as a medical scribe at St. Elizabeth Hospital in Enumclaw, and one day, right in the morning, one of the doctors runs up to me in the hall and he says, "Oh, you have to read this article." And it was this exact article, and the article basically says that in Canada, there is a black market that for the buying and selling of parasite eggs to treat irritable bowel disease. And I thought this was so awesome because irritable bowel disease is something that a lot of people have troubles with and don't get the right treatment for. And so some of the people that are having lots of trouble, they're trying to find alternatives. They're self-inflicting themselves with live parasites to try to treat their disease, which is amazing on a science level. So for those of you who don't know what irritable bowel disease is, it's an umbrella term for these three: Crohn's disease, ulcerative colitis, and irritable bowel syndrome. During the investment round, about 65% of the people that came up to my booth said that they either had it or knew somebody with it. I know soldiers that have been discharged medically from the military because of it, and I know some people that have actually died from these types of diseases. And the symptoms include debilitating abdominal pain, severe diarrhea, rectal bleeding, anemia, etc. And this is what a normal colon looks like on the left, and this is a colon with ulcerative colitis. And you don't even want to see what Crohn's disease looks like. It's just as bad. So, and this is a big deal for me because a lot of my friends, family, and even some of my coworkers deal with this disease on a daily basis. Their quality of life is significantly decreased. They're always looking for a bathroom. They don't get out of their house because they are worried that they won't be able to find facilities. They're constantly maybe hunched over. It's just, think about having diarrhea 3, 4, 5, 6 times a day. It sucks. So I've put together a great team to solve this problem. Stan Langevin, he's a biologist and geneticist from UW Seattle. He obtained his PhD in comparative pathology at UC Davis. Katrina Sells, who's the veteran on my team, she is an Air Force veteran with 7 years active duty, and she loves DNA and she loves microorganisms, so this is her wheelhouse. Josh Haney, who's an industrial chemist from Tacoma. He was a former biochemist from Revelesio, and he's actually the CEO of his own company, Footprint Bioscience. There's me, the student. I'm a student here at UW-T, and I have a real passion for medicine. I want to become a doctor and pharmaceuticals. And also David Hirschberg. Most of you probably know who this is. He's the founder of RAIN, which is a biotech incubator that's coming in just 2 blocks down that way. He got his PhD from the Weizmann Institute and postdoctoral education at Stanford in neuroimmunology. And RAIN is, David Hirschberg is the founder of RAIN, and it's a nonprofit biotech incubator that has offered to provide space for Helrus. RAIN is an incubator that his main goal is to catalyze the development of biotech and med tech in Tacoma, and to bring scientists here bring them here, bring them from Seattle, retain jobs in the South Sound. And it's not IBD and IBS is not only a big problem in the United States, but it's a big problem across the world. And it's interesting because IBD affects most regions that are first world countries that are very, very clean. You can see I didn't include in Africa or Asia or South America because they really don't have a problem with this. And there's this theory that that IBD is tied to this clean, where kids aren't being tossed in the mud. They're not playing in the mud. They're not. There's more bubble wrap around our kids, so they're not building up an immune system to parasites and things like that. So lots of Americans, 1.6 million Americans in the United States have this disease, and over 50,000 soldiers. 50,000 soldiers seems like a lot, but IBD has been linked to stress, and there's even some people in the crowd that know people that have IBS and IBD in the military, and over 80,000 children under 18 years, and it makes children susceptible to other diseases as well. So the market's huge. IBD it's about 16 to 28 million, or 28 billion, I'm sorry. That's from that's straight from Crohn's and Colitis Foundation. 31% of that market's hospitalization, 33% is outpatient, which is emergency hospital visits, and 35% is the medication portion, which I'm going to try to tackle today and in the future. So about $7,200 average cost. This is average cost per year, $7,200 per soldier, and even more expensive on the civilian side, about $13,000 per year. 50,000 soldiers times that 7,200 is about $350 million per year annually to treat these soldiers, and we have upwards of $20,000 up to $60,000, $70,000, $80,000 in the civilian world if you're looking at surgery for this type of disease. So the first step would be to get these worms. There's a specific worm that actually secretes a protein that has anti-inflammatory and immunosuppressant properties. So we're gonna get these worms. They live inside people, so they should be pretty easy to get. We're gonna microscopically harvest the spit, and at rain, we're gonna genetically map this protein and use CRISPR, which is utilizing the bacterial defense system, to genomically edit this sequence into yeast, so that yeast will actually grow up this protein itself. And they do the same thing with our artificial insulin. E. coli grow artificial insulin for diabetics around the world. We're going to grow and extract the protein. That's actually the apparatus that we're going to use to purify the protein. It's sitting at rain about 2 blocks away, ready to go. Just have to clean it up a bit. And then we're going to place that protein into a medication for use. And with all pharmacological endeavors, we've got a long timeline. We've got high cost. 3 minutes? Okay, so I got to go quick. So 2 years for development, 2 years for preclinical research, which is animal trials. We've got 3 to 4 years for human trials, and then an FDA review, and we're pushing it to market. So here's the financials here. So it's going to take about 200,000 to 400,000 to get it from parasite to protein, purified protein. And then the costs dramatically increase through clinical trials. You have to pay per person. But the great thing is that there's foundations and there's investors that are really looking for these compounds right at the edge of preclinical and clinicals. So if you've got the protein, it shows some type of efficacy. You've got people that are willing to invest big dollars to put it through these stages. Because as soon as you pass toxicology, the percent chance of success is 60-70% while you're going through the clinical steps. And then we broke Dane Jessen and I broke down the market. The total addressable market's about 1.6 million. We say the serviceable market's probably about 800,000. And our share of the market might be about 200,000. So we're taking quite a low portion of that. And based on our competitors and what we want to price this at, which is about $1,280, we're thinking about it's going to be about 1.1 billion in revenues per year. But the plan is after the protein is purified, we're going to license it to drug companies, because they've got the logistics, they've got the avenues of distribution. So we're going to leave that to them. And these companies tend to take about 20 to 40% royalty. When with the 20% royalty, we're looking at about $146 million a year for the company and for people that are invested in it. And over a patent lifespan of about 20 years, that's doing pretty well. So we've got a bunch of competitors, prednisone, which is a steroid medication, ibuprofen, and an immunosuppressant. All of these drugs, people are taking them right now, and they're not doing well on them. Ibuprofen can give you stomach ulcers. It's bad for your kidneys. Same with steroids. People with kidney diseases, people that have one kidney, they can't take it at all, so they're living with this disease. They don't have any alternatives, and Helrus can be that alternative. So if Helrus was given $50,000, I'd start writing grants right now because I'm going to need more cash flow. But there are a bunch of people that want to invest in this, and there are actually big grants for IBD specific. Time's up? Okay. All right. Any questions?
So I got a quick question. I'll lead off. Talk to me a little bit about your proprietary IP. As I look at this, you're harvesting the sputum from the parasites, and really what it looks like is your process is simply one of taking that and ultimately engineering it so you can get yeast to produce that.
Right.
Have you got anything in there that I guess I would say, is that process patentable? And if in fact it is, what prevents a potential competitor from coming in and again harvesting that sputum and producing a similar drug with a slightly different process?
Right. So it's completely patentable, and the actual protein is patentable, not the process. And so as soon as you patent the actual protein, you've got the IP completely covered. Did I answer your question? Was there another part to that?
Yeah,
sorry.
I think you're fine.
Okay. This process, CRISPR, is actually a fairly new technology. It's about 2 years old. And Stan Langevin is an expert in CRISPR, and so we're going to be able to do this efficiently and at a low cost because of this new technology. Thank you. What
is your role going to be in the company?
Right. So I'm very, very passionate about this, and I'm going to be helping the PhDs, David, Stan, and Josh Haney as much as I can. I can wash things. I can learn how to utilize CRISPR. I've got a lot of resources around me to utilize information-wise. I'm ready to learn all the ins and outs of what I need to do.
So who else in the market right now is doing this? Do you know? There's an article about it. Is there other people doing this right now? Or?
Right. So to my knowledge, there's nobody doing this. Patent search, nobody's doing it. I thought, no way. People have to be pilling this stuff up. But I think the barrier was the CRISPR, the more efficient genome editing. There's this thing called recombination problem where proteins don't fold correctly. But CRISPR allows a more efficient and a better way to do things. And that's very, very, very new technology. And so that's why I think that nobody's been doing this, because not a lot of people know how to use CRISPR effectively.
Thanks.
So you said you're going to take this for $25,000 and use it to start writing grants to amplify the effect for the funding? So
I'm gonna be starting to write grants for the rest of it, but we have space at Rain to start. We're gonna purchase the worms and equipment to start, and I'm gonna start paying the people that need to be paid. I mean, right off the bat, we have a lot of the equipment being built up right now. The labs are being built as we speak.
So how long will that $25,000 last you?
Not very long. But that's what a pharmaceutical company is all about. I mean, I gotta get on the grant writing.
Okay.
Well, to piggyback on that, you said it was going to take $200,000 to $400,000 to develop the protein.
Yes,
What goes right to make it 200, and what goes wrong to make it 400? Or
right. So that's time. I mean, I would imagine these processes are trial and error. The Stan and Josh Haney seemed extremely confident. They looked over my business plan. They looked over the science, and they said it's rock solid. But there's always problems when you're dealing with genomic editing and things of that nature. So $200,000 to $400,000, and when we're talking about a pharmaceutical company, a pharmaceutical development, $200,000 to $400,000 is a small bit in that piece. Thank you. Any more questions?
Are you using RAIN employees, or who would be the employees helping you initially?
So the team that you saw up there, I'm an intern at RAIN, but I'm going to be working on this project. And then also there's a new biomedical program starting at UW-T, and a lot of students would love to get to be a part of this. And so free resource lab techs. I've got lab techs that want to do capstones and final projects, and so that's a great source for labor and help.
Sure.
Curious, do you have any opportunities to accelerate the approval process with this drug, either through an orphan drug status or by going overseas and doing your trials?
You know, I didn't know that was even possible, going overseas to do drug trials. I'm not sure if that's actually a thing. I'm guessing it is because you've just told me. But that's something I am interested in as well. In this country, that process is pretty rigid. I mean, you're talking about 2 years, and it's going to take 2 years, or 3 to 4 years. It's going to take 3 to 4 years to get through clinical research, and that timeline's all based off of the FDA's is average. So many pharmaceuticals have been developed, and the average time.
How is the business structured? Who are your partners?
So I have a lot of support from Madigan, Multicare. RAIN has many connections around the South Sound. Madigan does clinical trials, and so the timeline will be cut short. I'm sorry.
So I'll just be a little bit more clear on that. Like, are you a sole proprietorship? Are you a partnership? Who's the equity partners in your business?
Oh, nobody. Just sole.
Just you?
Yeah.
Okay, cool.
So are you currently looking at raising funds elsewhere?
Yeah, and like I said, I'm raising grants. I'm going to meet with Jane Taylor in a few weeks from the Geneva Foundation, and they fund military-based research. So I'm going to be meeting with her, and there's large grants, up 150,000, multiple grants that go towards projects like this. And so if I can secure, just a few of those, we can get through to the development process, and then investors will hopefully be around for clinicals and preclinicals.
Thanks.